The ocean plays an incredibly vital role in regulating our planet's climate, often acting as a buffer against some of the most severe impacts of global warming. But today, we're going to delve into a phenomenon called ocean stratification, which appears to be undermining that critical function. Eloise, to begin, what exactly is ocean stratification?
Ocean stratification occurs when the surface layer of the ocean becomes significantly less dense than the deeper layers. Think of it like oil and water. They do not mix easily. This density difference creates a stable barrier, effectively preventing vertical mixing within the ocean. That barrier traps heat, nutrients, and even gases right at the surface, disrupting what should be natural cooling and carbon-sequestering mechanisms.
So, this barrier prevents mixing. What causes this increased stratification? Is it purely a natural process, or are we seeing human influence at play?
It's definitely driven by human influence. There are two primary causes. First, warming surface waters. As global temperatures rise, the ocean's surface heats up. This causes thermal expansion, reducing the water's density. Warmer, lighter water then stays on top, unable to mix with the cooler, denser water below. The second factor is freshwater influx. Melting glaciers and ice sheets release massive amounts of fresh water into the ocean. Since freshwater is less dense than saltwater, this further enhances the buoyancy of that surface layer, making stratification worse.
It sounds like a compounding problem. If mixing is inhibited, what are the direct consequences for the ocean and, by extension, the climate?
The consequences are significant. One major impact is reduced carbon sequestration. Without vertical mixing, the transfer of carbon dioxide from the atmosphere to the deep ocean becomes limited. That means more greenhouse gases remain in the atmosphere, accelerating global warming. Another consequence is increased heat retention. The ocean's ability to convect heat downwards is hampered, so heat stays trapped at the surface. This leads to rising sea surface temperatures and, critically, more frequent and intense marine heat waves.
So the ocean becomes less effective at absorbing carbon, and it also holds onto heat more readily. What about marine life? Does this affect ecosystems below the surface?
Absolutely, it can lead to marine ecosystem collapse. Stratification severely limits the upward movement of essential nutrients and oxygen from the deep ocean. This creates what we call dead zones, where marine life, especially phytoplankton, the base of the marine food web, simply cannot survive. When phytoplankton struggles, the entire marine food web is disrupted.
Dead zones are a very stark image. This isn't just a theoretical problem either. We're already seeing this happen. Can you put into perspective the historical trends and what this means globally?
Studies show that between 1960 and 2018, ocean stratification in the upper 200 meters increased by approximately 7%. That highlights a growing instability in the ocean's natural processes. What's particularly concerning is that ocean stratification creates a dangerous feedback loop. Warmer surface waters and reduced carbon sequestration lead to further warming, which then intensifies stratification even more. This vicious cycle accelerates climate change, increasing the likelihood of extreme weather events and ecological crises.
That feedback loop sounds incredibly worrying, essentially weakening the ocean's primary role as a climate regulator. So why does understanding the specific mechanism, ocean stratification, matter so much right now?
Yeah, it matters because the ocean's ability to absorb heat and carbon dioxide is diminishing. This underscores the urgent need for global efforts to mitigate climate change and reduce greenhouse gas emissions. Understanding these mechanisms and their cascading effects is essential for developing effective strategies. The health of our oceans and the stability of our atmosphere are inextricably linked. Addressing this issue is crucial for the planet's future.
This really highlights the urgency of addressing climate change and protecting our marine environments. Please consider sharing this episode with someone who might find this information valuable.